Hello. In this video, we're going to be taking a look at section 9.1, Evaluating Square Roots. Now in chapter 9, we will be looking at all there is to know about square roots, but we're going to focus on the basics in this particular section, and we're going to start out with just a little bit of review. So the first question is, what does it mean to square a number? Well, you have already taken a look at this in the past. So for example, if I give you the number 7 and I said square that number, you would probably say, well, that's 7 to the second power, which is equal to 7 times 7, which equals 49. And that's exactly what squaring a number means. Let's look at another one. If I give you 3, 3 squared, again, means 3 times 3, which is 9. Here's one that can be a little bit tricky because each of these previous two examples you could do on the calculator. And if you do choose to use the calculator, you want to remember that the square button is right kitty corner from the 7. And so if I wanted to do 3 squared, I would type 3 on my screen, and then I would hit the x squared button and it would automatically enter it on the calculator in this form here. And if I hit enter, I would get 9. You do want to be careful, however, with the number -2. So take a moment, see if you can square -2 on your calculator. Well, what did you come up with? Well, remember, with -2 squared, you are actually squaring a negative, and so when I write it, I would show it in parentheses, and again, what that means is -2 times -2, and a negative times a negative is a positive. So you should come up with a positive 4 on your calculator screen. If you didn't, you might have left off the parentheses. So remember, on the calculator, very important that you enter in parentheses anytime you're trying to square a negative number. Now, in this chapter, we're going to take and look at the opposite of. So what do I mean by this? Well, what I mean is that we are going to now, for example, look at when does x squared equal 49? In other words, it's going to equal 49 when x is equal to what number? Or if x squared is equal to 9, that's going to happen when x is equal to, again, what number? Basically, what we're going to look at is, in order to find x, we need to find a number that when we multiply it by itself gives us the given number. In other words, if I am looking again at x squared equals 49, what number can I plug in for x that when I square it is equal to 49? Well, we previously have looked at this up here at the very beginning, so most of you would probably go, well, yeah, x would need to equal 7. But the other number that would work here too is -7, because -7 times -7 is also 49. So what you need to remember here is that the number x is called the square root of the given number. So in our example here, if we look at the number 7, 7 is the square root of 49. Or we could also say -7 is the square root of the 49. So we're going to take a look at in a little bit more detail on how do we differentiate between these two numbers. So to investigate what a square root is in a little bit more detail, let's start out with the definition. So by definition, we say if a is a non-negative real number, then we say the square root of a is the positive or principal square root of that number a that we were just looking at. And we would say that The negative square root of a is exactly what I just said, the negative square root of a. So that is the notation we will use to represent what a square root is. But notice that the negative is on the outside of the square root sign here. Now, one other thing to note is that we also have the square root of 0, and the square root of 0 is equal to 0. That is a special case that comes up, and the principal square root is always a positive 0. So anytime that we are saying the square root of something, we will assume that we are talking about the positive or principal square root of a number. Now let's take a look at some other terminology that is associated with square roots. So let's start with for example, with the square root of 49. That's been my favorite number today. When we look at the square root of 49, we say that the number 49, or whatever number is underneath the square root, that is referred to as the radicand. That's a nice big word. So that's called the radicand. When we look at the square root symbol, that is often called the radical sign. And when we take a look at the entire expression together, the square root of 49, that is called a radical expression. So those are some phrases that you will hear me using throughout this particular chapter. Now, another part of the radical expression that we will want to take a look at is what is referred to as the index. And the index is basically what is the root of the expression that we're taking, because the square root is actually just one kind of radical that we can take a look at. It will be the most common one we'll look at. But when we look at the square root symbol here, or the radical sign, what it basically means is I'm looking for a number squared that will give me that radicand that would be underneath the symbol. And so this number 2 here really is the index. Now with square roots, we leave that off. Much like if I give you a term of x, you understand that to be x to the first power. I do not need to write that 1 up there. Well, with radical signs, if I give you just the symbol, the radical sign with no number, it is understood to be the square root. Now with that in mind, you may end up looking at some other radicals down the road. For example, we may have this symbol, which means the cube root. Or you might also end up having the fourth root. So there are other radicals that we will look at down the road. So when we're talking about a square root, the index that we talk about with a square root is this little 2 that we don't actually write when we use the symbol. Now let's actually evaluate a few square roots. Now here's one that we've already taken a look at a little bit, but I'm going to go back and look at it again. What is the square root of 49? Well, I'm asking you for the principal or positive square root here, so this would be 7. What if I ask you for the opposite of the square root of 36? In this case, I am asking you for the negative square root, so this would end up being a negative 6. If I were to look at a few others, for example, if I were to look at the square root of 16, what times what gives me 16? Well, 4. Again, that's the principal square root. If I take a look at the opposite of the square root of 25, that's going to give me a -5. You can also take a look at fractions. So for example, if I were to ask you what is the square root of 1/9, you could actually take the square root of that because the square root of 1 is 1. The square root of 9 would give me 3. So the square root of 1/9 is 1/3. Again, 1/3 times 1/3 would give me 1/9. Now there's a special case I would like to take a look at here. Consider for a moment the square root of -9. Now this is one we haven't looked at yet. So you need to ask yourself, what number squared would give me -9? Well, let's see, what are my options? I could take a -3 times a -3. Oh, but wait a minute, that would give me +9. A +3 times a +3 also gives me a positive. This is a little bit tricky. And the problem is that not all square roots will give us a real number answer. So for us in this particular chapter and in our course, we want to remember that the square root of a negative number is not a real number. So what you will want to remember is that square roots of negative numbers are not real numbers. And for this quarter, we will only be dealing with real numbers. So you will not be able to answer this square root of -9. You cannot evaluate it right now. So if I were to ask you that on a quiz or a test, you would simply tell me it is not real. Now, I want to make it very clear, it's not that there doesn't exist a value for the square root of -9. You will actually study it next quarter. It's actually called an imaginary number, but we're not going to go there at this point in time. So what this implies is that we actually can take square roots of any positive value. And that's what we're going to explore throughout this chapter. But for today, we want to look at a couple of specific types. Now, there are certain natural numbers that will give us perfect squares. And you are familiar with those. We've worked with those in the past. And so perfect squares would be numbers like 1, 4, 9, 16, and so forth. Again, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. Those are perfect squares that you have looked at in the past. Now, other ones, and all these are, so again, all of these here are in fact natural numbers. But we can also look at a few perfect squares that are rational numbers as well. So when we take a look at rational perfect squares, you want to be thinking about numbers such as 1/9. Again, we looked at that one earlier up here at the top, in that 1/3 times 1/3 equals 1/9. And so keep in mind that fractions could also work here. But then a lot of numbers that we will take a look at will not be perfect squares, and those will be our irrational numbers. Now, with irrational numbers, when we try to find the perfect squares, we will only be able to find approximate perfect or values that when multiplied will give us that number. So these will all be approximate values that we will take a look at. So let's take a look at when numbers are rational or irrational, and we'll do some examples with that. So let's take a look at some numbers and determine whether or not these will give us rational or irrational values. So for example, if I were to ask you to evaluate the square root of 625, you would find that it equals 25. 25 is a rational number. Again, it can be written as a fraction, and in this case, it's actually a perfect square value because 625 is a perfect square. What if I gave you the square root of 160? Well, 160, if you try to evaluate it, and about the only way you could do it right now is on a calculator, you would discover that it's actually approximately 12.649, and it continues on and on here. And anytime you get this non-ending, non-repeating decimal, you will find that you are dealing with an irrational number. If I look at the square root of 121, that actually equals 11. So this one again would be rational. If I look at the square root of 5, that is again approximately 2.236, and it keeps going after that. And so it is, again, irrational. So if you have a decimal that continues on and the key is it does not repeat, then you're going to be dealing with a square root that gives us an irrational value. And you'll have some of these in your homework to take a look at.